from India. Graded crop calendars and fertilizer application for South Asia.
I have been assigned the topic of talking about graded crop calendars and fertilizer application in South Asia. When this topic was assigned to me, I remembered one of our earlier studies more than 20 years back. We were doing and developed a spatial implementation framework of a crop model predecessors to InfoCrop, which was WT Grows, and where it used to run at a 10-kilometer grid size, and all inputs of weather spatial, soil, district level management practices, and remote sensing based crop distribution of wheat were implemented in this. In this, we did a study and showed that across those grids, if you give same generic most median rate of sowing, nitrogen, irrigation, practically you get no relation between reported yields and the predicted yield. Model is predicting something around a mean value. But the moment you assign the variable irrigation and nitrogen, and that to a district scale, from district we transferred to grids, the correlation changed from 0.16 to 0.53. And we used a remote sensing methodology to derive district scale data of sowing, and moment you put that, your correlation changes and it becomes mostly parallel to 1:1. So my point of showing this slide is the importance and sensitivity of models to the data of sowing, fertilizer and irrigation in simulating representative, truthfully, what is happening on the ground. Regarding crop calendars, I dwelt into some of our earlier studies, and in this I am not recommending yet anything, but at the end there would be something, but I am showing you how to do it about. What are the different ways to do crop calendars? It is one of the most important parameters to initialize the crop simulation models, and what we need is in terms of crop calendar is date of sowing, date of harvesting, sometimes date of sowing and duration of crop calendar, and many a times we need also well-defined phenological stages, their dates when they have happened, or in terms of days after sowing. The issues are that, one, the simulation models have very high sensitivity to this initial parameters because whole climate interaction is dependent on the sowing date, and the dates are always spread over practically. If you see we have a large variability in South Asian region. Date of sowings are spread even within a smaller region like a state. There is a variation from 1 to 1.5 months, and so we need a representative median dates. And for irrigated crops, we have already practiced varieties which are early sown, normal sown and late sown. So we need to decide on, if we want to do it at grid scale, what should be the weightage of each of this type of sowing date. Approaches of finding crop calendars could be, if we have field observations at whatever scale, farmer's field scale to district scale to state scale, grid them using some methodology. Solely using remote sensing, and it is becoming very common because it provides a reliable way of generating data of sowing, but quite computational intensive. We can do modeling in generating the dates of sowing with and without remote sensing. That was solely remote sensing, then modeling with and without remote sensing, and then combination of any of these above approaches. But before doing any crop calendar or data of sowing, graded level estimation, what we need is a very good cropland mask, irrigated and rain-fed cropland mask. I think that is another challenge which we would be discussing in, I think, subsequent parallel sessions. So practically cropland masks are not an issue nowadays. Only thing is, if we want to go back into history 20 years back, there may be issues. So already we have a good quality of cropland mask, but the issue is with respect to irrigated and unirrigated area mask, cropland mask. Just to give you an example, for South Asia ICRISAT for 2010 at 500 meter grid scale, they have generated, yellow is the unirrigated croplands and green is the irrigated croplands. And this is at 500 meter, then USGS it is for the global, they have generated at 30 meter for 2015. You see how much change is there in this region. We don't know whether it is actually there is a change on the ground or it is the methodology issues with that. So I think this is one more area where we have to, when we were talking of spatial implementation of models, we have to talk of what is going to happen to irrigated versus unirrigated maps at a very fine scale. Good quality maps need to be generated. So these are prerequisites. We don't have much time, but what we can do is, one of the ways is that if you have observations, whether at state or district scale, you would be always having a spread of dates. You have to find what could be a median date from expert judgment or observations, or we can again do a systematic literature review on that. Collect this database, georeference and transfer to the same administrative scale, and develop a relation between climate and environmental correlates with planting and harvesting rates like precipitation, temperature, ED, etc. And once you have developed with the observed data this kind of model, you can apply it over larger region. So this is one way of doing it. So this is being done globally, one of the way. Other is using remote sensing at a very fine scale, because you have a now long series of remote sensing data, and you can see the coming up and down of a vegetation index which shows the growth. You can clearly see, like for Northwest India, a growing season, Kharif season and Rabi season, and whatever you need a pre-processing in terms of removing such kind of noise in the data. There are different filtering methodologies. Or there may be regions where there is only one Kharif season, and this could be clearly identified in remote sensing data, and then using different thresholding and a way of finding the inflection points, you can actually generate the start of the season, mid of the season and end of the season, and then length of the season data, and even you can generate the early season portion, mid portion and late portion, but this could be region and crop specific for you want to generate such kind of gridded data. Like we did it for whole of Rajasthan, and we showed that for the drought year, then the total start of the season was quite delayed as compared to a normal year, as well as the duration of the crop season was much lesser as compared to a normal season. So these have a high reliability. This one example I have found for Nepal recently, this year only it was published by Mishra et al. From I think Tribhuvan University. For one district, they used similar kind of NDVI time series processing data to generate one season, start of the season in season 1. Actually this district is having 3 crop seasons, so monthly what is the distribution of start of the sowing in first season and second season, and also they have shown for third season. But this is only at a one district only, and crop neutral. One important thing is how to validate whatever you are estimating from remote sensing. We actually published a paper where whole of this is the wheat growing area for Southwest India, for South Asia, and then we had taken the 3 northernmost states, Punjab, Haryana and Uttar Pradesh, and actually find out using remote sensing the date of start, date of end for each year, and from some of the ground informations where reported growing degree days are there. We compared them, we calculated using these dates what are the growing degree days and what has been reported at the ground, and so we could find that what is the correlation between them, and if it is high, you have a high confidence of them. Or there is one important thing with remote sensing based finding the dates of sowing is that you can not only do a spatial gridding, but you can do a temporal disaggregation. Because if you see, we did a long time back a study on risk assessment to agriculture drought. It was only one hazard. So there is much variation in terms of the categories under early season risk, mid-season risk, late season risk, versus if you see whole season risk. So remote sensing has that advantage if we can think of. Other thing is you can do modeling with remote sensing, where actually this is for rice crop which is grown in southern India, Thanjavur district, and we put the leaf area index derived from remote sensing, filtered it, and what actually we did, we find out what are the unique growth profiles of leaf area index, run the simulation model in such a way that this profile of simulated leaf area index matches with that of what we are seeing from remote sensing. So once you iterate model with different date of sowing, the date at which this profile matches well with that, that is the date of sowing. So these are the class numbers, what is the date of peak LI and what is the date of sowing which we derived. Another thing is for unirrigated region, actually you have another way of doing it, especially for South Asia, because here the Kharif season rain-fed regions, their sowing dates are coinciding with the arrival and progress of monsoon. So we did one study in that where we used 47 years gridded daily rainfall data, converted to weekly rainfall data, and derived a method to find out what is the effective rainfall which should be used as a criteria for date of sowing. I am not going into the details, but then we could find out for whole of the South Asia how the different standard meteorological weeks they got distributed, and this is the median of 47 years of data. Regarding coming to gridded fertilizer application, this is quite a challenge. I would say not for us, it is globally. One approach could be we take district-wise data, map it to the districts, overlay to the grids, and whichever grid is filing in whatever nitrogen rate. So what we need is a crop-specific, district-specific nitrogen application rate, and this could be the starting point. Some of the global gridded fertilizer application data which I have seen, like from Raman Kutty et al., they are practically nothing but state level data transferred to map scale. So my summary is that accuracy of sowing date map is dependent on the accuracy representative of crop distribution and irrigation map. Sowing date should be mapped at much finer scale resolution than that of grid size. So if we are talking of a 5 kilometer grid size, our sowing date should be mapped at something like 100 to 50 meter and then aggregated to 5 kilometers using mode kind of thing. Irrigated crops can be, it is imperative to use remote sensing based approach because we have more than 20 years data at 500 or better resolution. For unirrigated crop, we can use a combination of remote sensing where we can do it or use climate modeling based approach. For crop specific fertilizer rate application maps, more research is needed. I really don't know at here what to do. But what I request that we should, all country teams should collect this observation data set of sowing date and fertilizer application rate which are crop wise and as finer administrative scale as possible. And for doing all this, we need really a high access to high computing resources. Thank you.
Dr. Sarat Chandran from India. He will do the presentation on genetic coefficient of TSAT for India.
Thank you, Chair and Co-Chair, and good morning everyone, my fellow ACASA members.